Hey everyone, welcome to Physics Explained chapter on vectors. Let's jump right in with the formulas that we've used.
Okay, so tying into the Pythagorean theorem, formula, you could use that to then find specific sides of a vector, such as listed here, vector C. You could find the horizontal and vertical components, somewhat incorporating that. Also using a sine theta that you could pretty much determine. You could choose yourself which one you would want to be the theta angle, and at that point you use that theorem to find the pretty much the measurements. Also, kinematic formulas can be used. One listed here is the velocity final squared is equal to the velocity initial squared plus 2 times the acceleration and the change in x. That's just the one that we ended up finding that we needed. However, it could pretty much vary within the questions and also the specific givens that are provided. I did a specific cosine theta value, sine theta value, or anything of that regard. And all you would have to do to isolate for a specific theta is you would just think the inverse, so the arc of that given measurement being sine, cosine, or anything. And at that point, that should give you the theta, as simple as that.
In this problem, we are looking for the tension of T3. And to do that, we are given that T2 and T1 are perpendicular to their corresponding wall, meaning that they're 90 degrees from each other. And so that means that T2 only has a vertical component and T1 only has a horizontal component. So what we need to do is we need to break T3 up into horizontal and vertical components. We T3 cosine theta as the horizontal component and T3 sine theta as the vertical to find T3. And since they are in equilibrium, we can put T3 cosine theta is equivalent to T1. T3 cosine theta is the horizontal component. And the same for T3 sine theta, which is the vertical component, with T2. And then you plug in and use the Pythagorean theorem to find C, which is T3. And then we get your answer is 94 newtons. And then B is asking for what the direction of the tension is, so we are looking for theta. So to do that, we take T3 and T3 cosine theta and we put that equivalent to T1. So T3 cosine theta is equal to T1, and then we plug in and get 94 cosine theta equals 50 newtons, and then we get cosine theta by itself, and then we find the arc cosine, and that gives us theta equals 58 degrees clockwise from the horizontal.
Okay, so to solve this problem, we start with the force of friction, which equals 0.55. Now to solve for the acceleration, which we need for the kinematic formula, we plug in the force, which is friction, which is 0.55, and the mass, which was given as 1,500 kilograms. And then we solve for acceleration, which comes out to be negative 5.39 meters over second squared. Then we use kinematic formula given here to solve for the initial velocity, and so the final velocity was 0. Initial velocity is to be determined. Acceleration was found here, and the change, the delta x, was given as 66 meters. So then we solve for all that, we get 26.67. 6 figs makes it 27 meters per second.